A vast display is unfurling as we talk, dazzling cosmologists around the world. Betelgeuse, the hypnotizing red supergoliath that decorates Orion's shoulder, is going through a wonderful transformation. This divine monster, known for its splendid red tint, has been a foundation of the colder time of year sky for centuries, drawing the stunningness and miracle of stargazers from old civilizations to present-day cosmologists. What makes this change so exceptional isn't simply the change happening inside the star itself, but the sheer scale and rate with which they are occurring. This monstrous star, many times bigger than our Sun, is showing us just how dynamic and eccentric the universe can be. Betelgeuse's radiance, the brilliant sparkle that characterizes its heavenly presence, has surged past its usual brightness by a bewildering half. Imagine a light suddenly burning twice as bright, projecting its gleam further and with greater power. That's what's going on with Betelgeuse. For a vast scope at the beginning of this year, Betelgeuse proudly held the distinguished title of the 10th most splendid star gracing our nighttime material. Its consistent natural light was a steady in the night sky, a guide of strength. However, this surprising divine shine-up has pushed it to a lofty new position, now shining brightly as the 7th star in our striking evening sky. This jump in brilliance has ignited fervor and interest within the galactic community, prompting new observations and studies to understand the mechanisms driving this sensational change. Betelgeuse, an enormous star in its late phases of life, is of monstrous size. Its aspects are huge to the point that if it were situated at the center of our nearby planetary group, it would extend equally as Jupiter's circle. Ultimately, this star will go through a breakdown resulting in a strong cosmic explosion, which may lead to the formation of either a neutron star or a black hole. The excitement surrounding Betelgeuse's cosmic explosion originates from the fact that it will be an unprecedented event, situated around 650 light-years away. Humanity considers itself in an ideal location to observe this invaluable exhibition firsthand. When the heavenly blast happens, it will deliver an amazing showcase of light. At first, there will be an unexpected inundation of neutrinos that will clear across the Earth, visible by observatories worldwide. Following this, high-energy photons escape from the growing cloud of heavenly trash. Betelgeuse will rapidly escalate in splendor over the course of 7 days, reaching up to 100,000 times its standard radiance depending on the blast's power. This heavenly guide could equal the brightness of a full moon and could even be apparent during daylight hours, casting particular shadows. This heavenly event will endure for a drawn-out period, offering astronomers an unmatched opportunity for detailed observations and possibly groundbreaking discoveries. While the cosmic explosion of Betelgeuse may trigger speculation and concern due to historical associations of such events with ill omens, we can take comfort in the fact that we are safely positioned at a significant distance, protected from any adverse effects, to fully enjoy the mystery surrounding Betelgeuse. It is essential to return to the end of 2019 when unconventional peculiarities began to manifest. During this period, the red supergiant star started experiencing significant darkening, a change visible even to the unaided eye. Observations using the Very Large Telescope in the optical range revealed that Betelgeuse appeared dimmer overall, but its photospheric layers showed signs of significant disturbance within our line of sight. The photosphere represents the outer layer of the star where light is emitted. Researchers also identified an expansion of the photosphere, giving the impression that the star was enlarging when seen from Earth. This expansion occurred at a steady pace of approximately 8 kilometers per second for most of the year until mid-November 2019, at which point the outward speed began to decline. By mid-November 2019, the flow of material from Betelgeuse stopped, prompting cosmologists to capture new optical images of the star. Their observations revealed 2 astonishing inconsistencies. Firstly, an obscured region appeared in the star's southern hemisphere, creating a striking contrast with a previous image taken at the start of the year. Secondly, the surface temperature of the star experienced a dip of approximately 80 Kelvin between January 27th and February 13th, 2020. The brightness of Betelgeuse reached an exceptional low roughly a year after the cessation of the outpouring. However, the star gradually regained its brightness over the following months, eventually returning to its expected magnitude. This led to the question, what had truly occurred with Betelgeuse? All the available evidence strongly suggested that Betelgeuse had undergone an immense and unprecedented event known as a surface mass ejection, SME. This peculiarity bears similarities to coronal mass ejections, CMEs, seen on the Sun. To better understand SME, imagine a volcanic eruption on a scale matching that of a star. Material from the star's interior surges up and outwards, causing shock waves within its atmosphere. Over time, this material forms particles and dust, partially obscuring our view of the star and making it appear dimmer. In the case of Betelgeuse, the SME resulted in the release of a mass 400 billion times greater than what is typically seen during similar events on other stars or CMEs, equivalent to many times the mass of the Moon propelled at incredible speeds. Experts noted that such a massive surface ejection from a star had never been seen before. The event allowed for the direct observation and evaluation of surface details using the Hubble telescope, providing a continuous insight into the aging and evolution of a dying star. The SME had a significant impact on Betelgeuse, causing it to lose a substantial amount of mass in a single event. This occurrence illustrated the fact that a dying star can undergo significant mass loss beyond its normal annual decline due to stellar winds. In a way, it was as if Betelgeuse had forcefully shed its upper layers and was now in the process of slowly recovering from the aftermath of this event. However, following this dimming event, the star's behavior has undergone a change. Previously, it would pulse or change its brightness every few years, but now it is pulsating at regular intervals. Betelgeuse is named a semi-regular variable star, meaning it experiences different patterns of varying brightness due to variations in its size and temperature. This red supergiant is known to display two principal periods of light pulsation. The first period lasts 400 days and is believed to be caused by pulses in the major mode. The second period is a longer cycle of approximately 5.6 years, and its origin remains unknown. In their research paper, scientists used programmatic insights to gain a deeper understanding of the events that occurred. They suggested that an unusually hot gas current, resembling a large and unique bubble, emerged from within the star. These occurrences of hot gas bubbles occasionally arise due to the star's turbulent and convective envelope, which can be likened to a pot of boiling soup where the material is constantly in motion and mixing. As this hot bubble climbed and broke through the star's surface, it triggered the release of stellar material. Interestingly, it also disrupted the star's usual pulsation pattern. The star's surface continued to expand while its deeper areas contracted, causing the star to change from its usual 400-day pulsation to a new 200-day pulsation. Astronomers speculate that the star's normal oscillations will gradually stabilize, correcting the unusual pulsation over the course of the next 5 to 10 years, ultimately restoring Betelgeuse to its expected 400-day pulsation. Regarding the probability of a Betelgeuse cosmic explosion, astronomers speculate that it could occur at any time within the next 10,000 to 100,000 years. Factors such as the star's variable brightness, size, and estimated age suggest this possibility. Researchers suggest that Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must continue through oxygen, silicon, and finally iron before the star's core collapses under its own gravitational pull, leading to a catastrophic explosion. Since Betelgeuse is located 650 light-years away, any cosmic explosion event occurring now would only become visible to us after 650 years due to the constraints imposed by the speed of light. Therefore, it is highly unlikely that we will witness the star's dramatic demise during our lifetime. The interesting thing about Betelgeuse is that we can actually see its surface, which isn't the case for most other stars. This gives us a fantastic opportunity to learn about how massive stars like Betelgeuse behave as they age, including these types of astonishing mass ejection events. Recently, astronomers made a surprising discovery. They observed a star eating its own planet 12,000 light-years away in the Ala constellation. Betelgeuse, with its distinctive name and prominent position in the night sky, has captivated the human imagination for centuries. Its significance extends beyond scientific knowledge, as it has influenced pop culture and folklore worldwide. Betelgeuse has a rich and diverse origin rooted in the Arabic language, initially translated as the armpit of the giant. Some scholars argue that it may represent a hand or shoulder. Nevertheless, This physical association is reflected in various interpretations of Betelgeuse, often linked